Welcome back, everyone, to Connect Day 2. That is right. I am James Montemagno. You saw me yesterday in New York for multiple sessions with Donovan, and I am just like him, crazy. Got on a flight back here in beautiful, lovely Seattle, Washington to talk even more cross-platform native app development with C# and Visual Studio. And today, I'm going to be talking about tons of awesome new stuff. You thought I had awesome new stuff yesterday? Well, even more new stuff today to show off and to talk about. I'm going to be doing a lot of demos both here on my Surface Book and on my MacBook as well, on both iPhones, Android devices, and a whole bunch of really good stuff. So I'm going to take you through a whole course, but if you're brand new and you're tuning in and learning about Xamarin for the first time, I'll also give you a small crash course on exactly what Xamarin is, how it works, and how it makes you build beautiful native applications for every single platform in C# with Visual Studio. So if you don't know who I am, I'm James Montemagno. I'm a principal program manager here at Microsoft. I worked at Xamarin before the acquisition. I was a Xamarin developer at a small startup out here in Kirkland, Washington, actually, building all of their mobile applications for over 2 years. So I've been doing this for 6 years now, and have built and shipped more than 70 apps across all the different platforms. So I love this stuff. In fact, I love it so much that I have a podcast where I talk about mobile and .NET development, and a show right here on Channel 9 called The Xamarin Show, where each and every week we release brand new awesome episodes talking about what's new in Xamarin, C#, and creating iOS and Android applications. So you can find me anytime on Twitter at James Montemagno. So let's get into it and really talk about why I fell in love with Xamarin and why developers have fallen in love with Xamarin. We have a really proud tradition of building native applications, native-first applications, and giving developers the ability to do absolutely everything on the platform. So if you could do it in Java, Objective-C, or Swift, you can do it inside of Visual Studio in C#. And finally, we really pride ourselves on same-day release, so giving you access to all of those great APIs. So what does it mean that Xamarin is native? What does it mean, that native actual term that I'm throwing out there? Well, you boil it down into 3 really important aspects that you need as a developer to create great apps, but also things that you want to deliver to your users. And I mean, not only do you want to share code across all your code bases and use amazing tools like Visual Studio, but you want to create great native mobile applications. So you want to build great native user interfaces for each platform, get access to 100% of the UI, so it looks like an iOS and an Android app because it is an iOS and Android app, or a Windows app, or a Mac app, or a Linux app, anywhere. And of course, you want access to 100% of those APIs. So if there's something you can do on the device, you should be able to do it. And then your app just has to be great. It has to be super performant. So I'll give you a quick rundown of exactly how Xamarin works and our unique approach. And what we do is we give you the ability to build out a shared C# business logic layer to your applications. So it's all your business logic, so models, view models, RESTful service calls, Azure integrations, things that are the same, just C# .NET code. Then you have access to 100% of the APIs in C# and can build out and craft native user interfaces for each platform. So if you're a Windows developer building for anything from WPF or UWP, you have .NET, this awesome library of goodness that you're used to. Gives you access to system.NET, I/O, HTTP, data, net, all those things that we know and love. When you want to go to UWP or WPF or some other Windows platform, you download an SDK and get APIs specific to that operating system. The same is true with Xamarin for iOS and Android. You get all of that .NET goodness running on our own .NET runtime that runs natively on each operating system, but also 100% API access for iOS and also Android, those boxes up top. And we create C# bindings around every single API. So you have access to 100% with C# features like async await, lambdas, events, delegates, things that you already know and love. So you have knowledge of that shared shared business logic, which is usually about 60 to 70, if not more, of your application source code. Then you can access all of those great APIs to really craft a rich application for every single operating system. When you think about .NET, we want .NET to go absolutely everywhere. And how we're doing that is standardizing a bulk set of all .NET into a single API that you can target that we call .NET Standard. You create a single .NET Standard library, and you can share that across any single operating system where .NET runs. So iOS or Android, Mac OS with Xamarin, UWP, ASP.NET Core, .NET on the desktop, anywhere. It kind of looks like this because there's even more. right? You're using VS Code, VS for Mac, Visual Studio, command line. You can target anything, traditional Windows, web apps, mobile, IoT, you name it, and you just have one big .NET Standard library that can be shared. And you can use a whole bunch of different code sharing as well. So you can have some .NET Standard, some shared projects, whatever you mix and match, along with all of that NuGet goodness of those great APIs out there. So let's talk about what we're doing when it comes to making your life as a developer love building applications for every single platform. What we're doing is we're simplifying the installation. We have a new minimal installation to get you up and running in under 5 minutes. We're giving you better defaults, better templates. We have a brand new first run experience that I'm going to show off that'll enable you to get started and get an app on your device in just a few minutes, but also rapidly iterate on your applications. We're always working not only on the installation, first run, but also to make you more productive, to get rid of kind of tedious steps in the process when you just want to modify a few things. So that's why first I want to talk about our Xamarin Live Player. Our Xamarin Live Player enables any developer to install Visual Studio and deploy their iOS or Android application on their physical device in under 5 minutes. And what it does, it'll send all of your source code over to the Xamarin Live Player app that you've installed from the App Store and interpret your code on the actual device in the app, which is really cool. So that means you don't even need to compile your application. You just see it running on your device. But at the same time, what it does is allow you to rapidly iterate on your application, which means that you can modify your source code and see it update in real time on the device. So here's how easy it is. So 3 steps. 1, file new, write some code. Pair your iOS or Android device with Visual Studio and see your app running. 3 steps, 1, 2, 3. And in fact, let me just show you what that looks like. So here I am over on Visual Studio 2017. And I'm using our Smart Hotel application that I demoed in the keynote yesterday. And what I want to do is kind of walk through some of the structure here. So I have my iOS and Android application. I also have my shared business logic layer. So I have models, view models inside of here. I have our views, which are shared XAML user interface. And this application is a hotel application for guests to go in and reserve hotel rooms and get into the room. So I actually have my Samsung device. This is a Galaxy S8, I believe, that I have screen mirrored side-by-side Visual Studio. And what I've done is I've installed the Xamarin Live Player application and I've paired it right under Tools, Xamarin Live Player, Manage Devices. You scan this QR code right here and over your local Wi-Fi, you're ready to go. So all you have to do is look at your drop-down. We'll see my emulators and my device that's plugged in, but also the Live Player, so Samsung Player. And all I'm going to do is hit debug. What this does, and just did, is over the local Wi-Fi, sent over all the files, and it built and interpreted it on the actual device. Now what's cool here is that I'm actually seeing the app running, and I can use it. So I can say James, password. And what I've done over in the code behind in my login view controller is added a breakpoint right here in the is validated. So when I hit sign in, I'm in a real live debug session. And I have all of my call stack, I have my output windows, I have my locals, I have everything that I would expect as a Visual Studio developer. And I can continue on and see my application. And we can see the rest of it here as I'm building it out. Now, if you were to take a look at this application, if we were to continue building the application out, I want to show you what it looks like to use the rapid design iteration with the Xamarin Live Player. So what I'm going to do is instead of just debugging my application again, I'm going to go into live run mode and we're going to build a new screen to this app. And I built it out yesterday. I want to build it again really fast so you can kind of see how it works and show you also how it works on Visual Studio for Mac with some of our new features. And what I want to do is add a brand new screen to add tipping to the app so anyone could tip like staff members. So I'm going to right click on any XAML page or any CS file and say live run. And what that does, it sends the single file over to the device to run. And I can start changing colors. So if I wanted to change this actual resource dictionary to red, for instance, it looks for my changes and then reinterprets that code without ever having to save the file. So let's actually change that back to white because red's not looking so great there on the device. So I'll just go ahead and say white. There we go. So it builds, it recomploys, and what it's going to do is take a few seconds because it's going to wait for me to stop typing, but it's also going to wait for me to reinterpret the source code. So now I'm going to go over, and I can tap it now on any single XAML view. So this is my menu view. If I go to my home view, we now have it inside of Visual Studio that it'll automatically change context based on what XAML file you're looking at. So I'm going to go over this tip screen, and it looks very generic at this point. So what I want to do is I want to put a profile photo. I want to put some message in there to leave a tip, and I want to add some buttons. Kind of if you've ever used Lyft, for instance, I want to put some circular buttons that the user can tap on. So I'm going to drag and drop in some code in here, and the first thing I'm going to do is add an image, put it in there. And this image has some data binding to my view model, and we have some margins, some widths in there, and that's looking pretty good. Let's also add a label underneath inside the stack layout. So I'll say leave a tip for James, and it's a little bit small, so let's change it to 30. That might be a little bit better. Let's see. There we go. It's looking pretty good, filling the screen nice. Now I have a grid, and what I want to do is add 4 different buttons in each column. So I'm going to go ahead and add down some buttons in there. And they're quite large because they're actually frames with a label inside of them, so they're a nice circular button. And I've added on each of them a tap gesture recognizer so I can tap on it. So I have no tip, $5, and $10. But let's add another tip option if we're feeling very generous. So I'm just going to go ahead and go on here and copy that. And then I'll just paste it here. And when I paste it, it re-evaluates, and we'll see it's actually a darker orange because it's stacked on top of each other. So let's go ahead and move that over to a new column. There we go. And we'll make that the default. So we'll change the background color right here. And we'll say that's a $50 tip. All right, that looks good so far. And then what I'll do is I'm going to go ahead and add a button in here to submit and leave the tip. So we have a button, it's leave tip. And what this is doing is this is all of our cross-platform XAML. It's displaying the native user interface on it. And it's actually not only just displaying my UI like a designer, it's actually running the source code. So if I actually tap and interact with it, we can see that I actually have some animations that are being displayed, which is actually really cool. And remember I said that there was a tap gesture recognizer here? That's because it's actually running the source code. In the source code here, it has a tap gesture recognizer, and it's scaling everything out to proper position. If I want to mess around with the source code, I can come in and adjust the scale over here. So I'll say, oh, maybe that's a larger scale. And now it's, well, it's really, really crazy. But imagine now that you're able to come in and say, well, maybe I want that to be 1.5, just a little bit more of a bounce in. And then when I bounce out inside of there we go, looks pretty good. Now it's looking a lot better inside of there. So I can not only rapidly iterate on my user interface without having to ever stop to debug or recompile or redeploy my application, but I can also run my source code in real time inside the Xamarin Live Player. But I want to talk about one thing that we haven't talked about, which we're releasing into preview. Because a lot of developers have asked us and said, it's great that I can use my iOS or Android device to actually deploy with the Xamarin Live Player, but what if I already have my entire development set up, ready? Can't I just use a emulator or simulator? Well, we're working on that. I want to show you what that looks like. So let's actually head over to my Mac. So we're going to toggle over to my Mac really quick, which actually has the same exact solution. Let's see if we can get my Mac up on the screen. Hold on one second as we get the Mac up on the screen. There we go, perfect. So I have the same exact application right here. And we can see it says leave tip, and I have all my buttons. Now the difference here is that I don't have my device at all. I am actually selecting my iPhone simulator right here, my iPhone 8 simulator. Now I'm not going to go into a full debug session because that would actually compile my app and rerun it. But what I'm going to do is I'm going to say run live run current view. And what this will do is it will connect the Xamarin Live Player to my simulator or Android emulator and start live running the application on my local machine. So it's going to synchronize, go through everything once it's launched. And what we should see here is the same exact application now running all 100% locally on my Mac. And the same for Visual Studio 2017. And what's great here is that now Wi-Fi is not part of the problem or part of the solution, if you will. So if you're on a plane or something like that, you can still develop. So I could come in and I could say, I really like that these buttons are really looking good, but what if I was to change that to 100? I'm still in live run mode, So it's going to update in real time. If I come over and take a look at the source code, I could come over and, modify the source code and have it actually redeploy and update on my device. I can see those huge animations that I had going on. At the same time, we can come in and modify the XAML. So this button, when I tap on it and I say clicked, run that method, it'll take any of my changes in the source code. And now when I hit that, it's automatically redeploying instantaneously inside of my iOS simulator. So these are ways that we're making you crazy productive to build iOS and Android applications with either nothing more than your iOS or Android device, or if you're in a full setup, you can go ahead and use the emulators and simulators, which is awesome. These are available in the new previews of Visual Studio. The Xamarin Live Player is also available inside of the stable Visual Studio today. All right, so let's hop back over into the slides here, and I want to talk about how we're enabling you to not only just build applications faster, but also to deploy applications faster. Because building is only half the challenge. You still want to be able to, deploy your application fully on a device, take advantage of all the capabilities, walk around your office and hand it over or deploy it on someone else's device for testing, especially when you're doing things like push notifications or GPS or something really complex. And kind of the struggle to do this on Android isn't so much, but the struggle is definitely real on iOS, where you have to worry about provisioning profiles, enrolling your machine, development, distributing. And you have to do this for both iOS development, ad hoc, in-house, and distribution. And you have to go back and forth between the portal and actually Visual Studio, back and forth and back and forth. Well, that is why we have integrated an amazing tool chain called Fastlane directly into Visual Studio for Mac. And we've optimized this in the latest version and introduced automatic signing of your application powered by Fastlane. And what I want to do is show you what this looks like back over on my Mac. So let's hop back over to my Mac, and we're going to go ahead, and I have my iOS physical device actually plugged in right here. There we go. So I'm going to put this over the simulator so you actually can see. I'm actually screen mirroring with QuickTime here so you can see the device. So what I'm going to do is I'm going to say File, New Solution, and we'll go ahead and save this currently. Save it all. There we go. And I'm going to go into an iOS app, and inside of Visual Studio for Mac, I'll take a few seconds here. If you've never used Visual Studio for Mac, you're able to build not only your iOS, Android apps. We have ASP.NET Core, Mac applications, IoT applications, tvOS, and all their cloud functions like Azure functions inside of here. So what I'm going to do actually is just build an app, and I'm going to build a simple single view app. There we go. And I will say connect 2017. And I'm just going to say, let's go ahead and target iOS 10, for instance. There we go. And here I have connect, and I'll say create. And now what I'm able to do is come in and go into my application. Now, inside my app, if I right-click and go to Options, what we're going to see is a whole bunch of signing identities. This enables you to select developer provisioning profiles that are on your machine, simulator, phone builds, anything like that. But what we want to do is try to get it onto our physical device here. So what I'm able to do is show you my machine setup. And the first thing I'm going to do is talk about certs and provisioning profiles. A certificate means that this machine is certified to essentially sign applications. So that's the first part. Think of my Mac as the one that is the certifier of the app. And then we have provisioning profiles. And provisioning profile says this set of devices for development or for the App Store can be signed with this certificate. So there's multiple things that you need to install. So on this machine, I actually have nothing registered. I have nothing in my provisioning profiles. So I'm going to go into my info.plist. And the first thing I'm going to do is select my team. And my team I get by signing into my Apple account via Fastlane. So we're using Fastlane tooling here. So I'm going to select my James Montemagno account, and I'm going to go say automatically manage signing this. And this will make sure I want to do it, and it'll automatically enable automatic signing of my application. So what this is going to do in just a few seconds is attempt to register my machine right here for my signing certificate, register my app ID, and my provisioning profile right there, which is really cool. All right, so now if I head back over to the actual portal and refresh my certs, there it is. There's my motsbook.local, which is really nice. If I go into development, there's my provisioning profile for this actual app. And then I can go into my app IDs and we shall see, there it is, my Connect 2017 all handled for me automatically. So at this point, I should be able to rebuild my application. And what this will do is take all of what I just told it to package up, so the signing certificate, my provisioning profile on there, and then it'll package up my actual iOS application. And I didn't even have to touch anything else on the machine, which is really amazing. So it's going to compile the entire application locally. We'll go ahead and see this compile up. Takes a few seconds because now it's actually going through a full compilation to go onto my actual iOS device. So we're building, building, building. Let it go for a few seconds. There we go. So now we're going to allow it to sign. So we'll say, yeah, go for it. There we go. I'm just going to hit debug. This is now going to deploy. I'm plugged in via USB, so it's going to now install the application on my actual device, which is really cool. Let's give it a few seconds here. There we go. Launch it here. And it's a blank application, so it's blank, as you can see. But I literally just have the app now running on my device. I can unplug it, I can take it anywhere, and I'm actually in a real live debug session right here on my machine, which is really cool. So that's how we're making it super easy to start getting up and running, not only building applications, but deploying applications. Then you can do everything else that you've seen with App Center, for instance, and Visual Studio Team Services to set up a full CI/CD pipeline to put it right into the store. But you have all of your provisioning profiles and everything set up. So let's head back over to the PC and slides. The other thing I want to talk about is something really unique to Xamarin, is that we give you every single API for every single platform you want to target. Whether it's Windows, iOS, Android, tvOS, Apple Watch, Android Wear, Android TV, Mac, Linux, you name it, we support it. And it's really important, especially in the world of mobile. We talk about how fast mobile is moving. We've already shipped same-day support for iOS 11, including tvOS, watchOS support, and Android Oreo support. So we're staying always up to date there with each operating system. And for Android, that means not only the core Android Oreo, it also means all the support libraries, Google Play services that are all exposed as NuGet packages, which is really cool. But you know, in the world of mobile, it's great to have the core actual APIs. But apps are a lot more than that. In fact, if you were just watching the previous session with Donovan, he talked about his backend services. He talked about his ASP.NET Core website. He talked about the migrations he had to go through. Because there's a lot of stuff, and that's where Azure can really help you out. Part of my job here at Microsoft is to work with every single Azure team and every team actually at Microsoft to ensure that there's a great mobile story. Whether you're building Azure Functions, deploying backend services with App Service or a Cosmos DB backend, you should be able to use all these great services. And something that I'm really excited for is the world of artificial intelligence and machine learning. So AI and machine learning are a real big theme not only of yesterday's keynotes, but also when it comes to the world of mobile development. These actual applications and devices are really powerful. You can do machine learning on the device, which is really great. And we offer a series of AI and machine learning tools that you can integrate into your mobile apps. And the first set is called cognitive services, which you've probably heard quite a bit about. But they have things like search APIs, speech APIs, vision, knowledge graphs, language services that you can use. But one of my favorite ones is how we're making machine learning actual easy with customvision.ai. Custom Vision is one of my favorite tools that we actually have here at Microsoft. There's so many of my favorite tools, to be honest with you. But it allows you to upload a set of training images that you can mark with attributes. You can train a model in the cloud and actually export an iOS Core ML model that you can use in a Xamarin application. So I figured what I would do to show you the power of not only just these AI and machine learning APIs, I also figured I'd show you how to use these for both iOS and Android, and use those brand new APIs of iOS 11 and Android O. So let's hop over to my Mac one more time. And what I want to do is I want to open my customvision.ai website here. And I'm going to sign into my account. And this is where you go, customvision.ai. We're just going to go ahead and log in. There we go. And these are all my projects. And what I wanted to do is see if I could create hot dog or not really fast. And in fact, the original application came from my good friend Frank Kruger, who's an absolute genius and has been on the Xamarin show and does a podcast with me. He created the original app and I extended it to Android. And he gave me all these great training models of hot dogs and not hot dogs. And I've been working and adding more on there. So what's great is you upload all these images, and I upload about 200 images to Custom Vision AI. So you can see there's actually Frank like cruising around the city. If I scroll down further and actually just tap on hot dog here, you can see all the great hot dogs, some with garnishes, some with relish, some without. Inside there's some images too, inside of there. And we have the not hot dogs. If I go, so these are obviously not hot dogs. Now what's really cool is that I can come into my performance tab and I can create iterations, okay, inside of here and train these models that I can then bring into my iOS or Android application. So what's nice is that first there's a prediction URL. Everything in cognitive services has a cross-platform SDK, but also a RESTful API. So got it. Now what's nice is that those are always available. So if you're online, you're able to actually hit those endpoints and use the SDK. But what if you're not online? What if you're on a train and you really need to see if that's a hot dog or not? Well, that's where the export button comes in, enabling you to export an actual Core ML iOS 11 API. And you can just one click hit export. So that's what I've done. I decided that I want to build this hot dog or not for both iOS or Android. So I'm going to come over and open over here another solution, which is, you guessed it, hot dog or not. So inside of this application, we have an iOS and an Android application. And first I want to focus on iOS. This is a Xamarin iOS application, so I have Xamarin iOS, nothing else. This is going to do everything on the device, so no internet required. So inside of here is that hot dog or not ML model. And this is a Core ML model, and it follows Apple's Core ML model. So if I actually double tap on that ML model, this is going to open up Xcode, which will show me what is inside of that Core ML model. So we'll give Xcode a second to boot up here. There we go. So this entire neural network, this Core ML image is about 3 megs that's bundled into my app. And what it does, it takes inputs and outputs. So think of it as a model of you give it something, it'll predict with those tags and give you some outputs. So the input is an image by 227 by 227, and it gives me a dictionary of string to double. So a tag of hot dog or not hot dog and the percentage that it believes it is. So we'll go ahead and close Xcode because that's all we need right there. Get out of here. So in this application, what I decided to do was use a bunch of the brand new awesome APIs in iOS 11 to actually find and render what I'm seeing on my device. And I can do that with ARKit, Augmented Reality Kit. It's the fastest way to get an image and video stream on the application, on the device. So what I've done is I've created an AR scene view. And this is kind of the entire view that's inside of it. And that's what I'm going to be displaying. And whenever I tap on the screen, it's going to generate a UI image view that I can then pass to this model. So this model is what I'll load, and then it's going to essentially pass it this Core ML request. So I have a model and a request, which is going to be passing the image in. So it's super simple code. So I first create my model, and inside of here, I simply give it the hot dog or not ML model. I can compile it up, make sure everything's successful. And then what I do is create my AR scene kit. I add a tap gesture recognizer onto it and add it as a subview. Then what I do inside of it is just set up my AR kit. So I just tell it, align itself to the world. And then whenever I tap on it, I tap on the actual view, I'm going to capture the current frame. And that's what I'm going to pass over into the request for classification. So whenever I tap on it, we'll go scroll down a little bit here, it's going to return a list of observations. And those observations are those tags and the confidence level. So how confident is it that it is a hot dog or not a hot dog, to be honest with you? And then I simply do a little pop-up here to tell if it's a hot dog or not. All right, so what I need to do here is turn on automatic provisioning for this application. Since I had it off earlier, it should go ahead and find everything. I'm going to set iOS as my startup application. And we will go ahead and wait for Visual Studio to reload. And I will say, let's go ahead and put this onto my device. And I'm going to go ahead and rebuild the application. So this will bundle up the entire iOS application. It will bundle up the Core ML model into this application, and then we're going to deploy it onto our iOS device, the physical one, since it actually has a camera on it. That's why it's actually important to get it onto the device, because we need to actually use the hardware capabilities of using ARKit, which is really nice. So we're going to give it a few seconds here to compile up this actual application and then get it onto the device. So we'll build, compile. And I am using my MacBook Adorable here with its M3 processor. So it takes a little bit longer to compile because it is adorable and rose gold. So there we go. We're successful. And I'm going to go ahead debug here. What we can do is we can, of course, do all sorts of nice little debug breakpoints inside of here. And we'll let it redeploy onto the actual device. There we go. And we can allow it to have the camera. And there it is. We can see it over there. So what's cool is that I actually have some photos up here of a hot dog. So we'll see how good it does here. So I'm going to hit hot dog, tap on the screen. We're going to hit a breakpoint over here. And we can actually see that the confidence level that is a hot dog is 99% confidence that it is a hot dog. So what I do is I display that I'm 99% sure that it is a hot dog. And that was all done on the device super crazy fast. So here I can say, is this a hot dog? Well, no, it's not a hot dog because it's a cartoon. The actual Core ML is so fast and so smart that it can actually figure out based on the training model. In fact, we can send Mooch over here and say, is a hot dog? No, it's not a hot dog. 100% sure that Mooch here is not a hot dog. Now, what's interesting about this application is that I said it was bundled into the app. But how do we get it onto Android? How do we get it also in a state where we're updating the model? In fact, we don't want to have to wait around for us to update the app. If I come in and I say train a new model and send a specific iteration, we can always be improving the model that we're generating. And you can do this on both iOS and Android. So what I've done is I've created a very simple Android application. And inside of here, it's based on a Xamarin Forms user interface. And I've added the Microsoft Cognitive Custom Vision Prediction Cross-Platform .NET Standard Library. So this will work on any single platform. It brings in a bunch of dependencies. And I've also brought in my cross-platform media plugin for Xamarin and Windows. So I can take a photo of anything from this app. So I just kind of did this really quick. In fact, I built this application in about 20 minutes on a train ride not too long ago. So this application is a XAML-based page here. So I have a button that says take photo, pick a photo, I'll display the image, and then I'll analyze the output and say, is it a hot dog or not? So the code behind could not be simpler to do this. The first thing that we're going to do is give it some credential endpoints for a prediction endpoint credentials and the prediction endpoint. And what this does is essentially are the tokens that I had in the customvision.ai. Whenever I tap on take a photo, I call a single line of code to give me a 256 max width or height image from iOS, and then I display that in the image view. When I click Analyze, I simply call Predict. This then takes it, puts it into a stream from the file, from the disk, and calls that endpoint. Literally one line of code to call into my custom vision backend. And just like I did earlier on iOS, I simply iterate through all of the predictions and see how probable or not it is that it's a hot dog based on, ordering. I'm using link, I'm using everything that I would expect. So now what I'm going to do is I'm going to go ahead and unplug my iOS device over here and plug in my Android device that I was using earlier. So there we go. I'll do this over here. All right. Let's get rid of there's this. So there we go. So now I'm connecting to my actual physical device. So what I can do now is I'm going to set Android as the startup. I'm going to go ahead and select my Samsung device. And I'll go ahead and add a breakpoint in the code behind and hit debug. Now this will compile up the Android application and then put me into a full live debug session. Now it's important that I have internet connection because I'm actually hitting that custom vision backend. And if you heard yesterday in the AI keynote, soon Custom Vision AI will also export a TensorFlow model that you could import into your Android applications, which is very nice. So we'll give it a second here to compile up and see what's happening on Android. All right. Building, building, building. And if you're curious, if you're kind of new to Android and iOS development, you may be wondering, well, is there provisioning or anything like that for Android? Because how is James just plugging in his device? Not so much on Android. You can just simply put your Android device in developer mode, which anyone can do, and enable USB debugging. It's very, very simplistic. It just takes a few seconds, which is nice. So no key stores or keychains or provisioning or cert or anything like that. All right, so now it's installing our application and synchronizing assemblies and launching it. There we go. Cool. All right, so let's go back over and I can come in and I can say take a photo. There we go. There's that lovely hot dog. Let's get that in there. There we go. I'll say OK. Now I'll say, is it a hot dog or not? This is going to take that and then pass it to the back end. It's actually really, really quick. So I can take a look at my observations and we can see that there was 2 coming back. I have hot dog, 99%. And then also not hot dog, where it was like 0.00001%. It's exponentially not a hot dog. So you can see how easy and those results are coming back and they're the same. So it's 100% sure it's a hot dog. But we can go in, of course, take a photo of Mooch. See what's going on, Mooch. Or is Mooch a hot dog? Analyze. Not a hot dog, 91% sure. So 9% sure, Mooch, you may be a hot dog, but a monkey for sure. Awesome. And that's how we're making it super easy to start integrating AI and machine learning into your cross-platform applications. Just super fun. All right, what else do we got? A whole bunch more. I am not even close to being done. And don't worry, there's lots of questions and I still have time to take them. So don't worry, I will get to them. So feel free to send them in. I want to talk about Xamarin Forms. Xamarin Forms is our cross-platform user interface that's all XAML-based and a whole MVVM framework as well. And we just launched Xamarin Forms version 2.5, and it's available today inside of NuGet, which is awesome. So what I want to do is walk through a few new features and talk about where you can take your cross-platform user interface and C# code with Xamarin Forms. So first things first, what if you're not building Xamarin Forms full applications? What if you're building an iOS and Android application and a Windows UWP application today? Or you're starting a new app and you're like, hey, I want that super fast, suboptimal, I want a really rich user interface. How do I add some XAML in it? Because for every page, you have to create it 3 times. Or if you're using Xamarin Forms and XAML, you can share your user interface. And a lot of apps have always wanted this. They're an existing application or a new app that's really media rich. So using storyboards and Android XML for some apps, and then cross-platform shared screens for the rest. And that's why we introduced native forms. Native forms is a feature of Xamarin Forms that allows you to simply throw some shared UI code in any existing UWP, iOS, or Android application. It's crazy simple, and I featured it yesterday inside of my session with Nat. It's just great. You take any page, you say file, new cross-platform XAML page, and you say to UI view controller, to fragment, and it converts it into a native element because it is a native control displaying native UI. Now we're always optimizing performance in Xamarin Forms. And in fact, we're doing quite a few things that are available in version 2.5. The first thing is fast renderers. And these are for your controls. The idea here is to reduce inflation of the user interface, which reduces the rendering costs by flattening the control nesting. And we do this with buttons, images, and labels today. And this gives your apps, from what we've seen, a 2x speed improvement when rendering those user controls. And that's really important when you have a list of data that is a whole bunch of, what do you guess, buttons, labels, and images inside of your app. The next thing that we've introduced, which is brand new, again in 2.5, is layout compression. So one are for your views, your controls, and one are for your layouts. Layout compression enables you to specify unnecessary nesting of your hierarchy. So on stack layouts, absolute layouts, grids, or relative layouts, you can say, hey, Xamarin Forms automatically enable layout compression and remove, if you can, this layout from the hierarchy. So what I'm going to show you is the same exact application on the left with no optimizations. It's a very advanced user interface. And the one on the right will have the layout compression. Or it's going to be in a GIF form, so it's actually going to rotate a few times. So on the left, this is before compression and fast renderers. You can see all the layers that are sticking out. This is using our inspector tool. You can see the layers of the images, the layers specifically look at the bottom Facebook, Twitter button, the layers and stacks of the nesting going on. The entire amount of renderers, as we would say, so any renderer on the screen for a control is 130. After turning on layout compression, that reduced it to 111. Once we turned on fast renderers for the images, buttons, and labels, that reduced it another 41 down to 70, nearly cutting it in half. So you can turn these on via the feature flags that I showed earlier on and off in your application. It's really awesome to see your applications come to life and be faster and more performant without very much work at all. At the same time, we're also making sure that we're staying up to date with the latest and greatest that's happening in iOS and Android. And with iOS 11, there's been tons of different UI changes for the iPhone 10, or X as I like to call it, such as safe area and large titles. So we have this really cool thing of on-platform specific implementations. And a lot of these are built into Xamarin Forms to do UI tweaks or customizations for iOS, Android, or Windows inside of shared code. So in the page, you can say use safe areas. So on iPhone 10, it doesn't, it'll make sure that your app doesn't go below the little swipe left and right that we can see down here in the bottom. And then large titles are these nice big large titles in your navigation that you're seeing over here. And you can say it prefers large titles. These are all documented and there's quite a few more. So really cool how the optimizations are occurring there. The next is our platform support. Now today, we support iOS, Android, Windows 10, absolutely everywhere, whether it's desktop, UWP, Xbox that you can roll out to. We've also shipped in version 2.5 our macOS desktop support. In fact, that was one of the questions from Anil. He said, when can I expect support for Xamarin Mac? Well, it's in 2.5 right there. Additionally, we've worked really close with Samsung, who has the Tizen platform, which runs .NET Core, and they're using Xamarin Forms for their user interface. So you can also roll out your Xamarin Forms applications to Samsung Tizen devices, which are watches, smartphones, televisions, and a whole bunch of other Samsung devices. Now, at the same time, we're also optimizing. So here, we're seeing some optimizations for macOS, such as adding context support, advanced animations, and navigation to make Mac applications on the desktop really beautiful. We're extending it, though, with some new previews that you can find on the open source Xamarin Forms GitHub page for both Linux and WPF that we've rolled out. So Linux is based on GTK Sharp that you can start rolling out today. Actually take a look, and this is a sample application on Linux over there. Now, one thing I want to talk about is that Xamarin Forms is truly powered by the community. We open sourced Xamarin Forms quite a bit ago, over a year ago, and we've had great response from the community. Not only have we showed you how to build it inside of Visual Studio Team Services with one-click NuGet for your own feed on MyGet, but we've got tons of great pull requests, feature additions, and a lot of things I'm showing you are built from the community. So what I want to do in this slide is I use an awesome tool to visualize the last 6 months of Xamarin Forms development in 30 seconds. This is going to show you all of the files that have been changed and all the contributors that have been changing. So I just want to watch you come to life how awesome all of you have been contributing to Xamarin Forms. It is absolutely amazing to see the community come together and really take Xamarin Forms to a whole nother level at platforms features that we could not have even imagined. It's unbelievable to see all of this. And every single one of those users are you, our Xamarin team, and the open source community working on this application in real time up until yesterday. And what this means is not only can we add new features, but we can add new platforms and new backends, as we call them. And there's actually been work to bring a Unity user interface to Xamarin Forms, which means you can actually build games, desktop, mobile, absolutely everywhere. But one question that has always come around was, what about the web? And something amazing that happened in the last few days by my good friend Frank Kruger is he built an ASP.NET Core front end for Xamarin Forms, which means that you can use your Xamarin Forms XAML user interface for .NET Core applications. He released it open source yesterday. So I want to show you, I'm going to put the GitHub up here, and it's essentially Xamarin Forms on the web. And it's called ooey is how you pronounce that. Ooey. He made sure that I said it really loud. So let me show you what that looks like. So I'm going to pull up Visual Studio 2017. Now what we have in here is the ooey open source. If you think of the web, there's an HTML, there's DOM, and essentially the HTML is sending that off to some server. It's requesting, how do I render a button? How do I handle events? Tell me what to do. So that's where ooey comes in, and it works as a little server that is essentially going to tell the web page with ASP.NET how to display the application. So we have ooey, we have the forms renderers. So he supports a bunch of different renderers, such as buttons, labels, box views, buttons inside of here, and some cool extensions for fonts and elements as well. So we have some samples, and what I'm going to do here is actually write a little Xamarin Forms XAML. So I'm going to come in, and we're just going to say stack layout, and we'll say padding of 20. And I'm just going to click your hello world, click a button, update a label. So I'm going to say label text equals hello from Xamarin Forms. There we go. Let's add another label here, and we'll give it a name of label count. And we'll say text equals click count equals 0. And then we're going to add a button on here. And we're going to say text click me. And we'll give it a clicked event of, I think I have it in the code behind here, of on button clicked. There we go. So essentially some labels, when you click this, go do something. So the code behind here is pretty simplistic. I have a XAML page. Here I have initialize component, and I'm going to increase the count every time. So I'm going to say label. There we go. Let's make sure that this is up and running correctly. There we go. Label count. Text equals, and I'll say clicked count. There we go. Now ideally, let's make sure this is going to compile up for me here. There we go. Should be working. All right. Now what I'm going to do is come over into my controllers, and I have a samples controller. So this is running the ooey, essentially to find all of my samples. And what it's going to do is create an element. And on this page, that's where ooey comes in to convert the Xamarin Forms XAML into an ooey element to display the Xamarin Forms native UI. So I'm going to go ahead and run this in IIS Express. It's going to spin up an ASP.NET Core website and server for me to actually start rendering an actual web site right here in Xamarin Forms. So here we go. Running on localhost. Give it a second to spin up. There we go. There's a bunch of different samples in here, but I'm going to go to the button page that I just created. And we can say click me right there. Click, 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 click. And I'm clicking it a bunch of times. Now you can see there are a little bit of issues because I didn't make that button big enough over here. So what's cool is I can say, let me give this a height request of 30. Redeploy really quick, make my changes to the website. And it's not only running my business logic and doing the UI, but it's running the full ASP.NET Core website, all powered by a XAML Xamarin Forms user interface. So there we go. That's looking pretty good. And it totally clicks. It's totally XAML on the web. It's not just that. There's also some really cool things such as a full clock powered by XAML. So truly taking XAML absolutely everywhere. So you can take a look at the open source contribute project to it. It's absolutely mind-blowing. I am blown away. All right, the last thing I want to talk about is some interactive learning that you can do. And the first thing, of course, is docs.microsoft.com. This is your one-stop shop for everything here at Microsoft. Whether you want to learn about Donovan and VSTS goodness, or App Center, or .NET, or Xamarin, or Bot Framework, or Windows development, everything is here for you. And in fact, what I love is that if you're brand new to C# or F# or .NET development or development of any kind, you can do interactive learning right in the browser. When people ask me, how do I learn C#, how do I get to become a mobile developer with C# with Xamarin, go to docs.microsoft, learn how to use C#, the great features, and you can run the code in the browser. When you're ready to go to the next step, we have Xamarin Workbooks, which is an interactive, now open source project where you can interactively write and execute logic inside of the Xamarin Forms desktop PC and Mac software, which is really awesome. What this allows you to do is gives you a REPL. So you have a full markdown file where you can interactively step through the different branches and see the application come to life. And you go to developer.xamarin.com/workbooks and find hundreds of workbooks to learn everything that I've shown you here. So with that, I want to wrap up by telling you to, of course, not only go to docs.microsoft, check out Xamarin Workbooks, but also check out Xamarin University, free interactive learning. There's a whole nother track going on here at Connect to learn how to build all this cross-platform app development. And we have a free self-guided learning and certification. And with that, I want to thank everyone. Make sure you check out the Xamarin Show. Follow me on Twitter. And I'm going to answer a few questions here. So the first thing is Ken asks, is the Smart Hotel application suite going to be open source on GitHub as a reference app? It will be. It takes some time. We clean it up. We just did it yesterday, and we're still demoing it here. So take a look. The next question from somebody is that the live player is awesome. They've already been using it. It's really great. In the past, they've used shared code projects and PCLs. Can it run with .NET Standard libraries? So today, we use shared projects and PCLs with the Xamarin Player, Live Player. We just rolled out a brand new release into App Center's Hockey app and Test Flight, which introduced .NET Standard support. You will need the latest preview of Visual Studio to get that support because there's some not only app integration and IDE work that had to be done just because of how .NET Standard works there. I think I have another minute or two. Is there any other questions in the stream? Let's see. Anything else? I don't know if we can scroll down there. There's some questions around some VS Max, some new project templates. There are some new IoT things. There's some Azure IoT templates inside of Visual Studio 2017. Be look, we're always updating, adding new templates and different work there for IoT integration. I think that's it. I've answered those two. I don't know if there's any more on the bottom. Question mark, question mark. Still on my screen. Blah, 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 blah. Cool. Does Xamarin Live Player, the app, it looks like build without debugging function. Does it work with only the UI? So Xamarin Live Player itself, there's two modes that I want to talk about. First is F5, debug mode, right? That redeploys the entire source code over to the Xamarin Live Player app and interprets your app in a real live debug session. That's not only running your user interface, but it's also running your business logic at the same time. The second part is our live run mode, and that go ahead and it deploys a single screen of your application and your business logic code behind. Now what's important there is it's not just your user interface with the live player, it's the actual source code. So when you saw me write that tip application, I was modifying the animations, I was modifying pop-up dialogues, I was integrating for not only the user interface, but the code behind. So you can not only use the Xamarin Live Player for your real-time UI modifications, but also for all of your C# source code, view models, RESTful service calls, things like that, which is really awesome. And then, of course, redeploy and reinterpret the app. So with that, I think I'm out of time. Thank you so much. Feel free to ask me any question anytime on Twitter at James Montemagno. Thank you so much. Have fun building awesome applications in C# with Visual Studio and Xamarin. And thanks for watching.